My name is Ni ILHAMI binti Ni IBRISAM. My matric number is P20EC3013. Today I'll be talking about free space management. What is free space management in operating systems? Free space management is a concept where the system will keep tracks of the free disk blocks for allocating spaces to files when they are created. It becomes crucial in order to reuse the space after deletion of files. It maintains a free space list which keeps tracks of the disk blocks that are not allocated to any sub-file or directory.
My name is ARIFUL, and now I'm going to talk about why we actually chose this cinema ticket booking system for our free space management project. I will actually briefing about the problem statement and how we find our proposed solution. Alright. So since free space management has been decided as the topic of our project, so we have started to find out the problem for its solutions, which is the traditional way to book a movie ticket is that the customer has to go that particular cinema hall or theater, and from there they have to manually buy the ticket, which is the cause of suffering of the users, because user need to go there and it can be late if he go there by late, so the seat will be allocated already, so he can get it. So we try to do it by online, and we believe if we do it by not manually, if we do it by with systematically, we believe that it will make the system more efficient by determining how many seats, empty seats are left, so users can right away choose the available seats in the cinema. And further, to visualize this implementation, we have decided to create an animation to simulate the process of determining the empty seats. So my friend Chen, he will describe about this visualization, but now I will explain why you choose bitmap for our project. However, there are a few methods for free space management that we can use, which was linked list. Also there is grouping or counting, but we choose bitmap. So bitmap, actually we decided to choose bitmap method because it's more simple and efficient for the cinema ticket booking system compared to other methods. Alright, now I'm going to talk about this bitmap or bitvector in a cinema ticket booking system. So why we actually chose bitvector for our cinema? So because when memory allocation takes place dynamically, it is the responsibility of an operating system to manage it properly. So we chose bitmap as a free space management technique because frequently the free space list is implemented as a bitmap or bitvector, so it's very easy to implement. So we actually decided to make our system like this, each block or each seat is represented by 1 bit. So when the block is free, when the seat is free, then it's set to 1, and when the seat or block is filled or allocated, so then it should be filled to 0. So 0, it means that block is already filled, and 1, it's free, block or seat already free. Let's take an example for our bitmap system. So consider a cinema hall where seats are 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 17, 18, 25, 26 and 27. They are free and the rest of the blocks are allocated. So what does it mean? This means block or seat 1, 0, 1 is already allocated, 2, 3 is not allocated, it's free, 4, 5 also free, 6, 7 is allocated, 8, 9, 10, 11, 12, 13 they are free, 14, 15, 16 they are allocated already, not free, 17, 18 they are free. I'm talking about the seats or block, yeah. And 19, 20, 21, 23, 24 they are not free, they are already allocated. 25, 26 they are free, and 27 are also free. So if I take an example from here, so suppose I pick 13 seats, just for an example. If I take 13 seats, so which is 2, 3, 4, 5, 9, 10, 13, these are free and the rest of the seats are allocated. So how we gonna explain this? So for this first, here you can see that there is a table. So for the first row, we took for the first row we pick this all about the seats or blocks. Then for the second row we took all about the bits. So as we talked before, we will place 1 bit for each block. So each block or each seat. So here you can see that we have 13 blocks. So if I talk about the first one, 0 already allocated, so this that's why 0 is here. 1 is already allocated, that's why the bits is 0. 2 is not allocated, is free. 3 is not allocated, it's free. 4 is also not allocated, so it's free. 5 also not allocated, it's free, so bit is 1. 6 is not free, 6 is allocated, that's why bit is 0. 7 is not free, 7 is allocated, that's why 7 is 0. 8 is not free, 8 is also allocated, that's why it is 0. And 9 is free, that's why 9 bit, that's why it is not allocated, and the bit is 1. 10 is also free, that's why bit is 1. 11 is not free, it's already allocated, so that's why bit is 0. And 12 is already allocated, and that's why bit is 0. The 13, the last blocks, last seed is not allocated, so that's why its bits is 1. So the free space bitmap would be 0 0 1 1 1 1 0 0 0 1 1 0 0 1. So that's all from our bitmap. Thank you.
Hello, this is student Ahmad ALMUNAJJED. I would like to explain why we choose bitmap for our real-life project. So, as we know that the memory space in the disk is limited, so we need to use the space of the deleted files for the location of the new files. So, one optical disk allows only one write at a time in the given sector, and thus it is not physically possible to reuse it for other files. That's why we choose the bitmap method for our system, because it has technique which is very efficient to find the free space on the disk. Thank you very much.
Seng, and my matric number is 3004. Today I'm going to present about my part, which is the animation of our project and the explanation. Basically, our project is about cinema ticket booking system, which is to determine the free seats in cinema halls using the bitmap methods. The bitmap method is under the free space management of operating system. For this image showing that a cinema hall consists of 5 rows along with A, B, C, D, E, and each row have 8 seats in total along with A1, A2, A3 until A8. This will be continuous to other rows as well. Each row also considered as one memory block. So for this hall we have 5 rows in total, so it's considered as we have 5 memory blocks in this cinema hall. For now, we're going to take the previous illustrations as an example. Since the cinema booking ticket hall is just opening for selling tickets and all the seats are available in the particular cinema hall. Okay, why so many 1 bits is represent each and every seats in the cinema halls? In this bitmap case, the system will determine either 0 bits or 1 bits in the cinema halls. Basically, the available tickets will be shown as in 1 bits and the book tickets will show in 0 bits. So that's why previous example, all the bits showing in 1 bit, which means in the halls all the seats is still available and no any seats has been booked. As we can see, the seats number B1, B2, B3, B4, D5 and D6 has been booked by the customer. Once the seat is occupied, then the seats bits 1 they will be changed to the 0 bits, which means the seat is already occupied and cannot be booked in the same section of the cinema hall. We have seen the example for how the tickets is available and how to determine the booking tickets in the bits of 1 and 0. But how to determine where is the free seats in the cinema hall? Okay, for that, each row has 8 seats, which means each row have 8 bits. Each row also considered as a group or a block. For example, the first row seats is A section and continues with B, C and so on. To determine the free seats in the cinema hall, the formula will be the number of the bits per row and the number of zero values in a row at the beginning before the allocation, plus with offset of first bits 1 in the non-zero word. This is mean we can calculate to determine which seats are free in the non-zero word, non-zero group or block. To determine it, we can scan the bitmap sequentially for the non-zero word. Example, the B seats row, the bits are 0, 0, 0, 0, 1, 1, 1, 1. Constitute a non-zero seat since all the bits are non-zero and there's available of the 1 bits which is available of free seats, but we don't know where is the free seats available in the. After the non-zero seats is found, we look for the first 1 bits in the row. This is the 5th bit of the non-zero seats, so the offsets equal with 5. Therefore, we can calculate the first free block number as 8. 8 is number of bits per row and times with 0, number of zero values in row at beginning before the allocations, plus 5. 5 is the offset, so equal 5. So this means the first free seats in the row B is equal at 5 seats, so the customer only can book the 5th seats onwards because seats 1 to 4 has been already occupied. Next, let's determine the first free seats at the row D. For this example, we also going to use the same example, same calculation formula as the previous. The D seats row, the bits are 1, 1, 1, 1, 0, 0, 1, 1, constitute a non-zero seats as well. After the non-zero seats is found, we look for the first 1 bit. Okay, for this is the first bit at the non-zero seats, so the offsets equal with 1. Therefore, the first free block can be calculated as the previous formula, such as 8 times 0 plus 1 equal with 1. So the first free seats in the row D at the first seats, also called D1. So from here, I finish my presentation today, and thank you.
Hello, assalamu alaikum. I'm SAAD and I'm going to talk about the conclusion. So we successfully completed the project and we figured out that we can make bitmap free space better. So the main concept of free space management and operating system is the operating system usually allocate free space to a new folder. So first of all, they actually create a list of free space. So when new folder is created or a new file is being created, so they search for the free space and allocate it